a little bit of more trig.
Okay.
So
Okay.
I'll try to.
Well,
So we ended on 52.
51, I think, because I remember saying
51.
area 51.
Oh, we finished 51, I think.
Right, I think so too.
And then we're on 52.
Talking about it. Remember,
that's what
it was a circle sitting up here, half of which was in quadrant 1.
Yeah.
So we figured out the area of the circle, took half of it, and that was our answer.
Okay. Okay, so 52.
Yuck.
So if A plus 2B equals 2, what is the value of all those letters? A plus 2B equals 2. Well, should we solve that? We can find, I was like maybe finding the value of A over B minus 1, maybe.
Well, notice
Could work.
that if we can manipulate this equation and solve for B minus 1, it's going to be quite helpful.
Yeah. So what I'm thinking, so A plus 2B equals 2. So
Can I somehow get a B minus 1 out of this?
Yeah, I think so.
Yeah.
Yeah, you can.
Okay, so I'm going to get 2B minus 2 equals negative A. And factor out of 2, B minus 1 equals negative A. So B minus 1 equals negative A over 2.
Yep.
So now, if I try to evaluate this expression, I've got A over negative A over 2. That's the first one.
Okay.
Second one, well, let's reduce that. What is that number?
Isn't it just negative A over 2?
It's negative 2. In other words, I'm going to solve this by flipping the denominator and multiplying.
Okay. Oh, yeah, okay. I understand
So this number is negative 2.
Okay.
So now we got negative 2 plus negative 2 squared plus negative 2 cubed.
Yep.
What is that?
So it's negative 2 plus 4 minus 8.
Negative 6.
So negative 6. Okay.
So I guess the moral here is they gave us an equation that had 2 variables and only one equation. So it's going to be impossible to solve for A or B from this equation.
Yeah.
However, that's why when I look at what they are asking us to evaluate, you want to see if I can somehow solve for B minus 1. I can't solve for B, and I can't solve for A, but I might be able to solve for B minus 1, and sure enough, it ends up being a pure function of A, and then the A's cancel, and I end up with numbers. So whenever you see something like that, always look to see whether you can make this thing look like any of these. Maybe I can make this look like A over B minus 1. Always the key when you have 2 variables and only one equation, usually they ask you not for each of the variables, but for some, like the last one. On an XY graph, 3 corners of a parallelogram are located there. Which of the following points could be the remaining corner? Well,
should we draw it at all?
If your life depended on it, you'd draw it, right?
Yeah.
Because you know you're getting it right. So whether we should draw it or not, I'm going to let you answer because it takes quite a bit of time.
It takes time,
Yeah. So you may only have to do No, we're going to have to do all the points. Minus 2 comma minus 1. That's right there.
Yeah, I don't know actually at all how to kind of solve these. I'm trying to figure it out.
That's what we have. Clearly, our other point has to be somewhere like there, right? The remaining corner?
Yeah,
I've connected these 3 points. We got a couple of possibilities, don't we? I didn't notice it first. We actually have a few possibilities. I could have a point up there. That makes a parallelogram. So let me mark these possible points with X's. I could have a point up there. I could have a point over there. And I could have a point way down here. Each of those 3 X's would make a parallelogram. Let's look at the possibles and see if any of them match. Well,
8-0 could work.
Yeah, it might. That would be right there. 8 minus 1 might even work. Minus 1, 9. Now we can cross that one out.
Yeah.
Minus 3, 6 could be that point right there.
Yeah, that can work.
Minus 5, 7 maybe could be that point right there.
Yeah.
So, what do we need to do to figure out what those points would be? Well, if this is the parallelogram, and this point, we don't know what it is. But we do know something about, let me think about this for a moment. We certainly know slopes. In other words, if it's a parallelogram, this side is parallel to this side.
Yeah, that's true.
Which means they have to have the same slope. This could get hard really quick. It already is. What's the slope of this line right there?
Oh, so sorry, say that again.
What's the slope of this line on the right?
So it'd be y2 minus y1 over x2 minus 3. Yeah, so y2 over y1. So you could say negative 4 minus 3 over negative 1. So it's negative 1 slope?
Hold on. We got minus 4 minus 3 over 4 minus 3. That's minus 7 slope.
Wait, 4 minus... Oh, okay, oh, that's right. I was trying to do it in my head, just to write it down.
What?
Okay.
So, no, I understand that. Okay, so we need this line to be minus 7 if this is our point. Well, gosh, got to be an easier way to do this, but not sure what it is. So let's continue on this path.
Okay.
So what were our possible points here? Minus 3 comma 6 and minus 5 comma 7.
Yep.
So minus 3 comma 6 or minus 5 comma 7. Which one of those in combination with that vertex gives you a slope of minus 7?
Negative 3, 6.
Yes. In other words, negative 3, 6 gives us a slope of minus 7.
Okay.
So that certainly could be correct. Now, all that tells us is that this side is parallel to this side. Well, for it to be a proper parallelogram, we got to prove that this side is also parallel to that side.
Yeah.
So what's the slope of the bottom line?
So let's see. So it's
I'm not sure I would spend this extra effort. Well, hold on a moment. Yeah, we have to. Because notice that just because this is parallel doesn't make it a parallelogram. If that point was up here, it would still be parallel to the other side, but it wouldn't be a parallelogram anymore. So we do have to check this final check to make sure this point gives us a slope of this line that matches the slope of this line. So what's the slope of the bottom line?
so of the two bottoms, those two. So -2, 1, and
Yeah.
4 are the
Yeah.
so it'd be -4 plus 1 over -2 minus 4. So so it's -3 over -3 over -6.
Well, we can tell it's a negative slope, so it must be 3 over -6.
Yeah, that's what I meant.
Okay? So the question is, if this other point gives us a slope of -1/2 on this line, then we have our answer.
Okay, so
And it does.
yeah.
So slope on that is -1/2. We have this side's parallel to this side's parallel to that side. That's the definition of a parallelogram. Wow. That is a hard problem, and I can't really see an easier way to do it.
Yeah.
I mean, even the reason it's so hard is that we were lucky we got it on the first point. I didn't even have to try any of these other points that I marked as possible solutions.
Yeah.
Well, I'm thinking there might be an easier way to do this, but I just don't know what it would be. Yeah, I don't know. I mean, it seems like it would be awful unfair to have a 3-minute problem on the test, but it seems like what we just looked at.
Yeah.
Okay, 54.
Okay, so Doug, who runs track for his high school, was challenged to race by his younger brother, Matt. Matt started running first, and Doug didn't start running until Matt has finished a quarter mile up on the school track. Doug passed Matt as they both finished their 6th lap. If both boys ran at a constant speed, with Doug running 2 miles an hour faster than Matt, what was Matt's speed?
Okay. So Doug doesn't start running until Matt had finished a quarter lap. So when Matt gets to there, Doug starts. Here.
Yeah.
Okay. Matt goes around, Doug follows him. He's always following him until the 6th lap. Both finished their 6th lap, and they'll be at the same spot. We need a master equation that relates distance, rate, and time. What is it?
Oh, for like,
Dirt.
Yeah, I'm trying to remember that, though.
Dirt. Dirt. Remember dirt.
Okay.
Dirt means distance equals RT.
Oh, yeah.
The way I remember it is that's dirt.
Yeah, I remember that.
Okay?
Okay.
So, what should we make our distance around the track? Let it be X.
Yeah, okay.
We'll say the distance is X around once.
Okay.
So, the equation for Doug. The distance is 6x, right?
Yep.
Let's not make that an x. That's a starting point. For Doug, his distance is 6x. The rate that he's running, hold on, let's go back and define a few variables. We'll make x be the distance around the track.
Okay.
Let's let y be Matt's speed.
Okay.
That means Doug's speed is y plus 2.
Yeah.
Okay? Now we should be able to come up with some equations.
Okay.
So, in other words, it takes Doug the same amount of time to go around 6 times as it takes Matt to go around 5 3/4 times.
Yeah.
So Doug's equation is 6x equals y plus 2 times some time that we don't know. We'll call it t1.
Okay.
Matt's equation is 5 3/4 x. That's the total distance he's going to go. His rate of speed is y, and his time is the same time because it takes Matt the same amount of time to go around 5 3/4 laps as it takes Doug to go around 6 laps.
Yep.
Okay. So, I'm thinking here. If I solve both these equations for t sub 1 and set them equal to one another, I can do that because that t sub 1 is the same number, whatever it is.
Yeah.
But if I do that, then I'm going to have 6x divided by y plus 2 has to equal 5 3/4 x divided by y.
Well.
That works. That's going to let us solve it. That's going to let us solve it. First, I didn't think it would because we have 2 equations, and we have 1 equation and 2 unknowns. But notice the x's disappear.
Yeah, that'd work.
Yes, it does work. I can cross that out with that, and now I have 6y equals 5 3/4 y plus 11 1/2. Subtract this from both sides, and you got 1/4 y equals 11 1/2. Y must be 46 miles per hour. Those are some fast runners. Yeah, real fast. All right.
Well, what I'm thinking is maybe 1/4 miles 1 lap, because I think it says 1/4 mile lap. So we could just say 0.25 is 1 lap. Maybe that would work more at all.
Hold on. I think I just did a math error is all. I got 6y equals 5 3/4 y plus 2 times 5 3/4. 2 times 3/4 is 1 1/2. Okay. Now I subtract 5 3/4 y, leaving 1/4 y equals 11 1/2. Multiply both sides by 4. I was so proud of myself. I thought for sure that was it. These two equations are correct.
Yeah.
if x is the distance around one lap, then he has to go 6x, 6 laps. And Matt only has to go 5 3/4 laps. Matt's going at y speed. The other guy's going 2 miles per hour faster. So if I solve that for t sub 1, I get 6x divided by y plus 2. If I solve this one for t sub 1, I get 5 3/4 x divided by y. And since the t sub 1's are equal to one another, I set that equal to that.
Yeah. Oh, I think that equation would work. Like the denominators would work. I think those are correct for the main equation you have. But I'm thinking like what they're saying is quarter mile. We could just say 0.25 is 1 lap. So if Doug ran, let's see.
Oh, I see what you're saying.
But 6, it could be just 1.5.
That won't matter, I don't think. Because the x's, in other words, it doesn't matter that we know what x is. You're right. You know what x is. In other words, if it's a high school track, so it's 1 mile around the whole thing. So I could even remove the x. In other words, the distance that Doug has to run is 6 miles. The distance that Matt has to run is 5 3/4 miles. Doesn't matter. The moment I still now solve for t, and I still have 6 over y plus 2 equals 5 3/4 over y. And that's going to give me the same solution. In other words, it doesn't matter how long the track was. It cancels out of the problem.
Okay. I was just thinking like 6 miles is, not 6 miles, sorry, 6 laps is, what's like 1.5? 1.5?
Oh, so you're saying that the entire track is a quarter mile.
Yeah.
1 loop. And Matt, okay, and Matt has gone around once. All right. So that would change things. It means that he only has to go 5 and he has to go 6. That means my answer is going to be 1y equals 11.5. Darn. It's not on there either.
Oh, dang. I feel like that would work though.
Yeah, I know. I agree with you.
Because 6 miles is, or 6 laps is.
I should be able to take this answer and divide it by 4 to come up with the answer. It should be 11.5.
Oh, wait. I think if they run 6 laps, it's 1.5 miles, and and Matt was, wouldn't it be 1.25?
I may be misinterpreting the problem. I'm not sure that they have defined the problem well enough to us.
Maybe.
Because all they say is that Doug didn't start running until Matt had finished a quarter-mile lap on the school track.
Oh, so what I'm thinking, maybe you can put the distances as, so if he did six laps, that's 1.5 miles. And if Matt did 1 less, then that's 1.25. Maybe we could, I don't know if that would work. Because that's how long, because he was down a lap. Or down a lap, I think, right?
Okay. I understand what you're saying.
But I don't know.
So you're saying the distance that Doug has to run is 1.5 miles. Doug is running at y plus 2 miles per hour for this amount of time.
Yeah.
That's Doug.
Yep.
Matt has to go 1.25?
Yeah. And then I think that would be, yeah, that equals
Okay, so now when I do the math, I get 1.5 divided by y plus 2 equals 1.25 divided by y. Now I get 1.5y equals 1.25y plus 2.5. Now I get a quarter y equals 2.5, and y is 10. And mat speed is 10. G. You got it. Very good.
Okay.
Very good. That was some kind of problem.
Yeah, I was going the same route you were.
Well,
And then
you got it right, and mine didn't produce the right answer. I'm still not quite sure why, but all right, let's see. Can you read 55?
Yeah. Let me get it. When calculating a certain tax, Simon found that no tax is due for all income up to P dollars. With P is greater than 0, income greater than P dollars is taxed at a rate of 15%. Which of the following graphs accurately represents this tax?
So the vertical axis is the amount of tax you have to pay. The horizontal axis is the amount of income you have. So does A work?
No, I don't think so.
No, because up to P dollars, and P is greater than 0, up to P dollars, you don't owe any tax. So there has to be a period on this graph where we start out at 0 and go at 0 for a while. And this would be P. And in fact, B looks like it would work. Only thing that I don't like about B, hold on, Simon found that no tax is due up to P dollars. Income greater than P dollars is taxed at a rate of 15%. Well, it can't be A, it can't be C, it can't be D, because D fits, except then at some point it flattens out, and not if you have to pay 15% of every dollar over P. So,
well, for
E can't be right either.
No.
So it's got to be B.
Yeah.
B is the only thing that fits. You pay no tax up to P dollars, and then starting at P, it's linear. In other words, you pay 15% of every dollar. Now, what confused me at first is I'm looking at a slope of 1. But we really don't know what this slope is. It looks like a slope of 1, but that's because we don't have a grid anywhere on our axis. So that doesn't have to be a slope of 1, even though it looks like a 45-degree angle. That could certainly be a slope of 0.15. Anything. It could be a slope of anything. The only thing we know is it's linear. It's a straight line. It has to be a straight line. All right.
Ooh, trig function. Ooh.
All right. Just in time.
Yeah, I think I can figure this one out.
I think you can too.
Alright, let me try. So the following figure is y equals 5 sine x over 2. Which of the following answers are correct, amplitude and period? So the period's what? 4 pi.
Good.
And then the amplitude's 5, so it'd be
Good.
8. Yeah, there we go.
Very good.
Finally. I remember when I couldn't get this.
57.
Okay. So if the equation x squared plus mx plus n equals 0 has two solutions, x equals k and x equals 2k, what is the value of mn in terms of k? Oh, okay, I know what you can.
Okay?
So you can
Yeah.
do. So you can put k to the for x minus k. You can put k to the other side. So it'd be x minus k equals 0. Same for the 2k. So it'd be x minus 2k equals 0. And then you can put them in a parentheses x minus k, and then parentheses x minus 2k equals 0.
Multiply these out. What do we get?
Let's see. So it's x squared minus x squared minus 3kx plus 2k squared. I kind of skipped the middle.
Okay, I like it. Let me just erase that number and that term, and it's 3, right?
Yep.
So we have x squared plus 3kx plus 2k squared equals 0.
So we just need mn, or no, yeah, mn.
Well, we know
so,
n. We know n is that.
Yeah.
So n equals 2k squared. What does m equal?
Negative 3k. Okay. Yeah, negative. Oh wait, no.
Not negative.
It's,
In other words, all you need to do is equate these coefficients. If this is this, and it is, then I know m is equal to 3k, and I know n is equal to 2k squared.
Okay.
Now it says, what is m times n in terms of k?
D? Wait.
Yep. 6k cubed. Mm-hmm.
Okay. Whoops. Okay.
All right. Let's see if we can do these three in the time that we got left here. Some of these are easy and some aren't so easy.
Yeah. Yeah. It's weird. Okay. So 58.
Mm-hmm.
When she chooses a password, I'll just call her, I don't know, Elise, I'll call her, always uses exactly 10 different characters, 5 letters, A, B, C, D, and E, and 5 numbers, 2, 3, 4, 5, and 6. Additionally, she always ensures that no pairs of letters is consecutive, and that no pairs of numbers is consecutive. How many different passwords conform to these rules? Confirm, yeah.
There's our 10-character password. How many choices? This is always a choice question. In other words, problems like this, I mean, it might be a combination or permutation problem. It probably is, and if you knew how to set it up as that, that'd be the way to do it. But personally, I find it easier to look at the first character. How many choices do we have on the first character?
10, I think.
How many choices on the second character?
5.
No pair of letters is consecutive, and no pair of numbers is consecutive. We can repeat. We can repeat, though, right?
Yeah.
So how many choices on the third?
4. Right. Or would it still be 5?
5. We have five letters that we could choose. And then 5 numbers, and then 5 letters, and then 5 numbers, and then 5 letters, and 5 numbers, 5 letters, 5 numbers.
Okay.
Now, okay, you got a calculator. What's 5 to the 9th power?
Let me check. It's 5 to the 9th. Okay, whoops, my calculator's turned off. That's, whoa, okay. Oh, okay, my calculator's glitching out.
Okay, here, let me do it on my...
Yeah, let's wait one.
My little calculator
Golly
won't do
God.
that. Is yours working or not? Otherwise, I got to pull out my Inspire and turn it on.
It says more than 1 million, so I don't think that's not right.
Well, no, hold on. Look at the answers. Now, we have to take this 5 to the 9th and multiply it by 10. So even if 5 to the 9th is over 100,000, we know our answer. It's K.
Uh,
5 raised to the 9th power.
yeah, mine says it's like 1 million, 1.7 million or something.
Well, then multiply by 10, we're fine. It's greater than 1 million is the answer.
Oh, okay.
In other words, 5 to the 9th is 1.9 million. So therefore, if we multiply that by 10, it's over 10 million. So the answer is definitely K, more than 1 million. Now,
Okay.
did I do that right? Let's see. She can use exactly 10 different characters, never doing a pair of letters. Yeah, so that 10, 5, 5, 5, 5 has to be right.
Okay.
Yeah. Okay, how about 59?
Okay. So, if the least common multiple of 9, 10, 12, and V is 540, which of the following can be V? Let's see. So I'm trying to just do this as fast as possible.
Well, tell me what you're doing. How are you doing it?
Well, I was trying to look at the least common multiples of each one. And I'm pretty sure B can't be right at all, because 540 is not I think it's not a multiple of 24.
Well, okay, that's what I was asking, was your process. So we can see if any of these answers if all of these answers are factors of 540. Well, yeah. Let me divide 540 by 24. That's 22 and a half, so you're right. So it can't be 24. Could it be 18? Well, 18 certainly goes into 540, but so does 27.
Yeah.
It says the least common multiple.
I don't know if I was thinking of a different one. I don't know if it would work.
Well, let's look at these. Let's look at our problem. Let's see if 18 is the answer. Yeah. Well, the least common multiple means that it would be the lowest number that all four of these are divisible by.
Mm-hmm. Oh, I think I figured something out.
Well, clearly 540 has to be divisible by 9, 10, and 12.
Yeah.
So I think we want the least number Now let's check a couple of these. We know it's not 24, but it seems like it could be 27 also. How do we figure out which one of these is correct?
I don't know if I was trying to think of something, but I really don't know if it'd work out.
Well, if 18 is our answer, and I had these four numbers, is 540 the least, oh, hold it, is 540 the least common multiple? I'm not sure it is. I'm not sure 270 wouldn't be. 270 is divisible by 9. It's divisible by 10. Is it divisible by 12? No. So 270 would not work. In other words, I'm trying to figure out if 18 is V, would 540 be the least common multiple? In other words, and I'm not sure how to find the least common multiple, to be honest with you. Yes I do. I have to take this number and keep multiplying it until everything is divisible by it.
Oh.
Keep raising.
Okay.
In other words, it's the same process for finding a least common denominator. In other words, I have to check 36 might be the least common multiple. 18 is divisible by into 36. 12 is, 9 is, but 10 isn't. So now I try 54. 12 isn't. 72. 10 isn't. And I would go up, up, up until I reach 540, presumably. Wow. Got to be a better way to do this.
Yeah, I'm trying to think of a way, but I really don't know if it'd work out.
Can I tell? In other words, I know that all of these divide into 540, but I also know all of these divide into 540. And it's possible that using 18 might give us a least common multiple that's less than 540. It seems like it should be.
I think I don't know if this would work, but I could try something.
Okay, what are you thinking?
So I'm thinking the least common multiple of 9 and 10 is 90, I think.
Yes.
Yeah. So the least common multiple, I'm leaving out V for now.
Okay.
Of 9, so the least common multiple 9, 10, and 12 has to be a multiple of 90. Wouldn't it?
Yeah. In fact, has to be a multiple of 90. Also has to be a multiple of 120. And a multiple of 108. Doesn't it have to be all of those things? $90.
I'm thinking if you go 9, so you can go 90, 180, 270. 180 is a multiple of 12.
Aha. There you go. 180 is the least common multiple. If 18 was our answer, they all divide into 180. Good thinking. That means that's not the right answer. And notice 27 does not divide into 180. Evenly. Well, I still don't know how to find least common multiple.
Yeah, that's still
don't know how to
kind of
find
stuck.
it. This is a hard problem to solve. What we did prove is that 18 isn't the answer. In other words, if 18 was V, the least common multiple would be 180. If 18, it can't be 24, because 540 wouldn't be the least common multiple. It could be 27. The question is 540 the least common multiple? Probably is. Makes sense. It's not going to be 270 because 12 doesn't go into 270.
Well, the thing is, ugh. Can you? No, that won't work.
What did you find? You found 180, which was a third of that.
Yeah.
Well, for 27, I can't find a least common multiple that is a factor of 540 in other words, if I take half of that, I get 270, which is divisible by 27, 10, and 9, but not divisible by 12. So to double that to 540 would make sense. I think this is the answer. I'm just not sure I can prove it. I don't know how to find least common multiple. I didn't realize that. Between a bunch of numbers. Let's go on, since I can't be of much assistance here. Let's see if we can get 60 done before we're done here.
Okay.
And I don't know what to do on that problem. I'll think about it. And if I can think of an answer, we'll talk about it next time. But
for next, because Thanksgiving is next Thursday, right?
yes.
Would you want to change the time, or do you want to go the next week following?
Well, it's completely up to you.
I'll have to talk to my mom.
I'm available that day.
Okay.
So if you want a session, I can do one that day.
Okay. It just might be an earlier time. I'll have to talk to my parents.
Okay. I'll leave it blank for now.
Okay.
And get back to me if you want a session. We could even make it a different day if you want, or just skip it altogether. It's kind of up to you and your parents.
Yeah, I'll definitely talk to them.
Yeah. Since you get the whole week off, it might not be bad to have a session. I mean, especially if we're just using it to practice for ACT.
Yeah.
All right. So problem 60. Y equals A times X to the B plus C produces 3 coordinate pairs. What is the value of A, B, and C? Okay. I don't see an easy way to do this, but I do.
Yeah, I know how to do it. It's just going to take a little.
You know what? It may not take as long as it looks because of that 0.
Oh yeah, because you can replace 2 with the Y.
Yes. We know what C is immediate. No. Let's see.
Not right away, but
we know that 2 is equal.
No. Yeah, you're right. You could find out C is
2 is equal to C.
Yeah.
Okay, and now we know that 7 is equal to A times 1 to the B
plus
2. And we also know that 42 equals A times 2 to the B plus 2. So there are 2 equations and 2 unknowns. We can solve for A and B. And in fact, A is 5.
A is 5. So 42 equals 5 times 2b, or 2 to the power b plus 2. This would be 40 equals 5 times 2 to the 8 equals 2 to the power b. 2/3 equals 2 to the b. B equals 3. That changed the base thing. I completely forgot about that.
2/3 equals what?
2 to the third equals 2b.
Oh, 2 to the third equals 2
to the power b. Yeah.
So b equals 3.
Yeah.
So A times B times C is 30.
5 times 3 times 2. Yeah. So.
Good.
Yeah.
Okay.
I'm going to definitely try to figure out how to do 59 at the same time. Later this week sometime.
Yeah, for sure. That's worth knowing, how to find a least common multiple between a bunch of big numbers. So I'll see if I can figure that out also. So I may talk to you next week. I may not. I'll wait to hear from you. Just text me or
I'll text you in the next couple days.
email me or something.
Okay.
Okay. Otherwise, I'll just assume there's no session, and I'll talk to you 2 weeks from today.
Okay. I'll text you and let you know.
All right, Anthony. Have a good Thanksgiving if I don't talk to you before then.
All right, cool. You too.